Okay, so we're going to work problem 2.39 for statics. And this problem is a little complicated. We're going to try to find an alpha that is going to result in a horizontal and then find the resultant. So the picture from the book has this 110 Newton force up, 85 newtons at alpha, 170 at alpha measured from there. Okay. So the first thing that I would do is I would draw a free body diagram. So that's this over here, and I simplified it dramatically. I took the collar out and all that jazz. It really is just three forces. The 110 that's up, the 85 at alpha, and the 170 at alpha. Okay, so I'm going to write these three forces, and I'm going to write them, I've labeled them here, 1, 2, and 3. And I'm going to use that labeling then to write them out. So, okay, here's force 1, and it's only in the J direction. It's 110 newtons. Force 2 has components in the X or I and the Y direction, the J direction. And we can write those in terms of this component direction, which we've done many times, right? So if I wanted to sort of highlight that, I could. Let me pick a different color. We'll make them blue. Okay, so we could say, well, all right, there's this X component and this Y component. And for the third force, there's an X component, right, and a Y component, right, just sort of drawing them out. Okay, let's go back to our highlighter. So third force, F3, we can write it out that way. Notice the minus sign for the downward J component. Now the constraint in this problem is that there is only a horizontal resultant, which means that the Y component of the resultant must be 0. So that's my constraint there. So I'm going to write them together. They're going to only have an I component or RY 0. So I'm going to use that, and I'm going to say, well, RY equals 0. And then I'm going to sum together these different forces in the Y direction. So let's go back here, and we'll go back to red, right? And so we've got a Y, and a Y, and that's what we wrote, right? We wrote them all out, the 110, the 85 sine alpha, and the 170 cosine alpha with this minus sign here, okay? Okay, so the tricky part at this point really is that you've got this sine and a cosine together, right? You can't divide out, because then you end up with like a tangent and a 1 over cosine, which is pretty ugly. So what we're going to do instead is we're going to use a trig identity. We know that sine squared plus cos squared is 1. We're going to use that trig identity to write the cosine as 1 minus the sine squared with that square root. Okay, so given that, I can now kind of rewrite that equation on the next page. That's what I did here. It's the same equation as we did before, right? And now I'm going to try to get rid of that square root. So I'm going to move that square root term over to the left and move everything to the right. So now I've got this 170 times square root minus 1 minus sine alpha squared here, and then this term on the right. And then I'm going to square both sides. That's going to get rid of the square root. And then I'm going to have everything in terms of just the sine function. So when I square this term on the left, I end up with that. And then squaring this on the right gives me the 110, this guy, and then this cross term, which comes from doing this square of the right. So we can put it all together, and we get 0, that's the Y component is equal to 0, is to this huge, kind of ugly looking expression. But it's written in terms entirely of sine of alpha. So I'm going to do a substitution. I'm going to say, well, suppose sine alpha is just some number q, and it is, it's a number. So then I could write it in terms of this same expression, except now I've substituted in q for sine alpha. So q squared q and then a constant. It's a quadratic equation. And if I solve that quadratic equation, I get two possible solutions. And the one that's interesting is this positive one, right? I mean, it looks like the angles have to be positive. So I know that the sine of alpha must equal that number, so I could then find alpha. Alpha is 28 degrees, 28.0725 degrees. Okay, so it's kind of a technique for being able to turn everything into an equation for just the sine of alpha. Okay, so now we know the alpha. We'll go back and look at our expression for the force 1, force 2, force 3, and we can find the x component, right, by finding this plus this, that's what we did here, and put in the number, and we get actually kind of a nice number, 155 newtons. And just to check, we should be able to say, well, all right, what about in the y direction? So now that, and that, add them up, and sure enough, when you do, you get 0 as you expected. So the tricky part in this problem was probably getting rid of that technique of getting rid of the cosine as the square root of 1 minus sine squared. Fun problem.